Pythagorean trigonometric identities. Sin square a plus cos square a equal to 1. Tan square a plus 1 equal to secant square a. Cos square a plus 1 equal to cosecant square a. These three are called Pythagorean trigonometric identities. To derive these identities, we have to know the basic elements of a right angle triangle. In this triangle, angle B is a right angle, and with respect to angle A, BC is the opposite side and AB is adjacent side. AC is hypotenuse. And also we know all different 6 trigonometric ratios like sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta, how to write these depending upon a triangle. Now when we combine the knowledge of these two, from a right angle triangle, we know that hypotenuse square is equal to square of opposite side plus square of adjacent side. Just substitute the values here. Hypotenuse is AC. So AC square equal to opposite side is BC. We are considering for angle A. And adjacent side is AB. So we will write this as AC square equal to BC square plus AB square. Now divide the entire equation with AC square and it will get modified like this. Now this can be rewritten like this, means we are writing it as numerator by denominator whole square. AC by AC, the first term on the left hand side will get cancelled out and it will become 1. BC by AC. From the triangle, it is opposite by hypotenuse. Opposite by hypotenuse is nothing but sin A. So we substitute this with sin A. And as we have square for that, we write it as sin square A. Now the next term is AB by AC whole square. That is adjacent side by hypotenuse. Adjacent by hypotenuse means cos A. So we write this as cos A square. So this is the first identity we have, that is sin square A plus cos square A equal to 1. Now in this identity, if we just transpose the cos square A to the other side, it becomes minus cos square A. Now we have sin square A equal to 1 minus cos square A. And from this we can write sin A equal to plus or minus root 1 minus cos square A. In a similar way, if we transpose sin square A to the other side, we will get the formula for cos square A. And cos square A equal to 1 minus sin square A. This can also be written as cos A equal to plus or minus root 1 minus sin square A. When we know the value of sin A, we can find the value of cos A like this. And if you know cos A, we can find the value of sin A as well. These are the identities that involve sin and cos. Now consider the basic identity we have got. Sin square A plus cos square A equal to 1. In this, divide the both sides with cos square A. The equation will get modified like this. If we rewrite this as sin by cos whole square, now this is the equation. Sin by cos is nothing but tan A. Cos by cos A will get cancelled out, so it makes 1. And then 1 by cos A, that is reciprocal of cos A, is nothing but secant A. Now we have got another identity, that is tan square A plus 1 equal to secant square A. In this also, if we transpose 1 to the other side, we will get another formula, that is tan square A equal to secant square A minus 1. From this, tan A equal to plus or minus secant square A minus 1. Or from the original formula we have got, that is tan square A plus 1 equal to secant square A. Try transposing tan square A to the other side. That makes secant square A minus tan square A equal to 1. Now from these formulas, consider the last one, that is secant square A minus tan square A equal to 1. It is like A square minus B square. We know that A square minus B square is nothing but A plus B into A minus B. So using that, we can write this particular equation as secant A minus tan A into secant A plus tan A. And this is equal to 1. I just transpose any one of these. It is like AB equal to 1, from which we can write it as A equal to 1 by B or B equal to 1 by A. So one term would be the reciprocal of other. Just I am transposing secant A minus tan A to the other side, and that gives the formula for secant A plus tan A. Or in case if we transpose secant A plus tan A to the other side, it gives formula for secant A minus tan A equal to 1 by secant A plus tan A. So this gives the second set of formulas from the Pythagorean trigonometric identities. The first one is the basic formula, and rest all we have derived from that by transposing the terms to the other side. Now coming to the third identity. For that also we will consider the first identity first, that is sin square A plus cos square equal to 1. This time we'll divide the entire equation with sin square A. The first one will become 1, as it is sin square A by sin square A, that makes 1. Then cos by sin is nothing but cot, so this becomes cot square A. Reciprocal of sin A is cosecant A, so we'll write this as cosecant A. 1 plus cot square A equal to cosecant square A. This is the third identity. Now we will just try to do the transposition, and that gives us few more different formulas. Let us start with that. Initially we will write the formula and then we'll transpose 1 to the other side. That makes cot square A equal to cosecant square A minus 1. Take the square root. Cot A equal to plus or minus root cosecant square A minus 1. Now, instead of transposing 1 in the formula, if we transpose cot square A to the other side, then that makes the formula to be cosecant square A minus cot square A equal to 1. From these formulas, again if we apply A square minus B square equal to A plus B into A minus B here, it will make cosecant A minus cot A into cosecant A plus cot A equal to 1. Again transpose any one of these to the other side. So it gives cosecant A plus cot A equal to 1 by cosecant A minus cot A. This is one of the formula. And if we transpose the other term, it gives cosecant A minus cot A equal to 1 by cosecant A plus cot A. So this gives the remaining formulas. These three are the basic Pythagorean trigonometric identities. If we rearrange the terms, we will get different formulas.